Hello everyone. My name is Satyakam Pratap Singh, and this is the ninth tutorial session of the network analysis course. Whose instructor is Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur, and I am Satya. I am PMRF research scholar here at Department of Energy Science Engineering, IIT Bombay. So in the last tutorial session, we have seen the how to solve the problems related to basically uh, symmetry and that kind of problem. So in this tutorial session, we will see the how to solve the two-port network-based problem, basically. So this problems, let me move to that first. What is actually the two-port network, basically? So if you see the statement, what is written here, a two-port network is a mathematical model which is used to describe the electrical circuit that have two pairs of terminal, one pair of for the input and one pair for the output. It means that if you see here in the image, this is the input port and this is the output port basically. And this is the terminals. If you see, this is the 1 dash 2 2 dash, and the V1 is the voltage across the input terminal, and the voltage across the terminal output terminal is the V2. And the current which is entering into the two-port network is I1, and the current entering from the output side into the two-port network is the I2. So this is the general convention we follow for the two-port network. And also if you see that these networks are widely used to model the systems like amplifiers, basically electronic circuits like amplifiers, you got filters, transformers. So there is two-port parameter characteristic, the behavior of the network in terms of the voltage and current at the input and the output side. Okay. So we try to find out what is basically the relation between the input and output parameters based upon some characteristic behavior of the network. Okay. So main two-port network parameters, we actually see the Z parameter, impedance parameter that is called as Z, admittance parameter that is Y, hybrid parameter that is called as H, and the transmission parameter that is called as ABCD parameter. Getting my point? And also the last is the advert. This is the conductor, basically the G parameter of a two-port network. So now what are the two-port parameters mainly? Z, Y, H, ABCD, and the G. Okay. So these are the five parameters which you have to see what is the actually the uh, parameters in terms of the input voltage, input current, and the output current. If you see the properties of a two-port network, some important properties exhibited by the two-port networks are the linear and the lump circuit. Okay, a two-port network demonstrates linear behavior, meaning superposition it holds. Okay, and it also follows the lump element approximation. It means that this two-port network, when you are having this two-port network, you can apply the superposition because it will follow the superposition because it's a linear circuit. Okay, and also it also follows that the lumped element approximation. If you have this distributor parameter, you can approximate it to the lumped parameter, and also it follows the property. There is a reciprocal is one of the property. Here is the thing is network is linear and passive. It satisfies the condition of reciprocity where the mixed partial parameters are equal. It means that when you exchange a place of the source and the output, you can get the same result. That is called as a reciprocal basically. And if you see the Z12 and Z21, this we will see in the future slide that what is actually the meaning of Z12, Z21, Y12 or Y21 and so on basically. And the causal is basically the output cannot precede the input. It means that when you are starting the input, at the same time only the output will start. It will not the thing is that output should start previous to the time. Okay, suppose this is the T naught time frame, you will get the output at the time T naught only. You will not get the output T naught minus 2 seconds. It means that the time it got started, after that or at that time only the output response will increase or basically the change. It will not the case that it will start previous or prior to that. Okay, this is a concept of causality. Time invariant, that network behavior does not change over time for a fixed set of inputs. It means that it is not a time dependent parameter, so it actually the follow that it is a fixed parameter basically. Suppose you got Z12. Okay, so this is a time invariant parameters. You will not say that okay, this is the varying with the time, so it is a constant value. Deterministic means if the specific input will always produce the same outputs. It means that, let me see with the example. This is the case. Suppose these are the different parameters in the two-port network. So which we have studied Z, which is most important, that you should know that what is the relation between the source and the output side parameters. Z, Y, H parameter, T parameter, or the G parameter. Okay, this is a 5 parameter, basically very important for the analysis and all. So if you see the Z parameter here, let me go into the detail of that. Just duplicate it. New slide. So let's see in the detail. Duplicate. So the Z parameter, which we are actually observing here. So the Z parameter, if you see, this is the Z parameter. So in this two-port network, which is the two-port network, basically we've seen as like this. This is the voltage across it V1. This is the voltage across it V2. And the current which is injected here is the I1. And the current which is injected here is the I2. Okay. And this is the two-port network. So how to represent? In these cases, the V1 will be equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Okay. If you wanted to write in form of the matrix form, it will be equal to V1 V2, which is equal to Z11 Z12 Z21 Z22 times of I1 and I2. It means that what is the meaning of Z11? Z11 basically means it is the ratio of the input voltage to the input current when the current I2 is equal to 0. Okay. Similarly, when you find it out the Z12, it will be equal to V1 by I2 when the I1 is equal to 0. I1 is equal to 0 means it is the from the source side, source side is open circuited. It is basically open circuited. When you see here the I2 is equal to 0, it means that the output side is open circuited. Okay. So what is the value of Z21? Z21 is basically equal to V2 by I1 when the I2 is equal to 0. And similarly, the Z22 is equal to V2 by I2 when the I1 is equal to 0. Okay, this I2 and I1 similarly, that output side is open circuited or the I1 side is input side is open circuited. Based upon that, we will get the Z11, Z12, Z21 or Z22 parameters. Similarly, if you see here the Y parameters, if you see that I1, I2, Y11, Y12, let's take that how to see the Y parameters. When you see the Y parameters, similar manner that Y it is in the term of I1 is equal to Y11 V1. Let me remove this. Y parameters. So the I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. Okay. So if you wanted to write in the form of the matrix, you can write it as I1, I2 is equal to Y11, Y12, Y21, and Y22. This is equal to V1 and V2. Okay. So what is the value of Y11? Y11 is equal to I1 by V1 at V2 is equal to 0. Or if you wanted to write I12 is equal to 0, it will be equal to I1 by V2. Or if you wanted to write Y21, it will be equal to I2 by V1 at V2 is equal to 0. And this is the I1 by V2, which is equal to V1 is equal to 0, or Y22. Y22 is I2 by V2 at the value of V1 is equal to 0. It means that what is the value of the V1 or the V2 is equal to 0. V1 is equal to 0. It means that source side is short circuited basically. Or if you see that if you are getting V2 is equal to 0, it means that output side is short circuited. Getting my point? So these are the parameters which I have given that. So this is a Z parameter. V1 is equal to Z11 I1, Z12 I2, V2 is equal to Z21. So the matrix which you got, the Z matrix, it will be equal to Z11, Z12, Z21, Z22. So important point to remember here is that what is the input parameter? Input parameter here is the V1, V2 is equal to Z matrix, and you will get the I1, I2. Similarly, when you see in the Y parameters, you will get I1, I2. If you face any doubt in between, just let me know. Is equal to the Y matrix, V1, V2. And this input parameters you have to remember. Basically, V2 is the input parameter in the Z, and the I1 and I2 is the Y parameters in the parameter. I1, I2 is the input parameter in the Y matrix basically. So what about the H matrix? H matrix is basically what is the input parameter? V1 I2 is equal to H matrix is equal to I1 V2. Similarly, the transmission parameter, that is ABCD parameters, there the input are V1 V2. This is the V1 V2, which is equal to, this is a matrix. So this is basically the V1 I1, and it is equal to ABCD parameter ABCD, and here the current direction is opposite, V2 minus I2. Why it is opposite? It means that suppose when this is the two-port network which I have shown, the I2 if you see here is actually entering into the two-port network. But in the ABCD parameter, it is assumed that it is going out of that network, because the transmission side, you always send the power from the source side to the receiving end side, means sending inside to the receiving inside. That's why it means that the current is leaving from the sending in to the receiving end. That's why it is kept at the minus I2 basically. What about the G parameter? G parameter here is the, what is the input parameters here? I1 V2, which is equal to G parameter G matrix, and then V1 I2. These are the simple things. Just you have to remember that what is the input parameters basically. This is the most important to check and cover the questions. Okay. If you wanted to take the screenshot, you can take that. Okay, let's move forward. Let's move forward. What we have covered currently, we have covered that what is the two-port network. After that, we have seen that what is the properties of the two-port network. Then we have seen what are the input parameters in the different two-port networks. Two-port two-port networks, that is Z, if you are getting the what is the input variables, what are the output variables into that. Let's see the few things are there like you have to remember that what is the symmetry and the reciprocity conditions for the different matrices. Okay. If you're taking the Z parameter, the condition for symmetry is that Z11 is equal to Z22. And the condition of reciprocity is that Z12 is equal to Z21. And same for the, if you see the Y parameter, it is actually equal to the Y11 is equal to Y22, Y12 is equal to Y21. So this is basically the reciprocity or simplicity. The ABCD parameter, A is equal to D parameter and AD minus BC. It means that ki A, B, C, D parameter what you have got, its determinant is basically 1. Okay, so that is the thing. Now let's move to the first problem of our. Try to solve it and let me know. So let's understand the what is the meaning of this symmetry or the reciprocity basically. Then after that you can clear your concept. So there are two conditions, two things are there. That is the symmetry and the reciprocity. Let's see the what is the meaning of reciprocity. Reciprocity means if you are having the two-port network and this is the V1, that is a plus minus, and this is the V2, plus minus V2. And the current here coming is as I1 and here coming as a I2. Suppose you wanted to exchange the source, so this is the source and this is the output terminal. When you wanted to exchange the output with the source, or you wanted to exchange the source with the output or the output with the source, in that situation it is called as reciprocity basically. Getting my point? So the meaning of reciprocity is that when you wanted to exchange the output with the source or the source with the output, in that situation the circuit or the circuit topology remains same and you get the same output. Either side you take the source, either side you take the output. That is called as reciprocity. And the symmetry means when you give the input from the any of the sides, you will get the same type of output. It means that when the two-port network basically, if the input-output port can be interchanged without altering the port voltage and the current, that is called as the symmetry basically. Okay, so that is the meaning of symmetry. So there are different conditions related to that. That Z11 should be equal to Z122, Z12 is equal to Z21, Y11 is equal to Y12, Y21 is equal to Y12. These are the few conditions for the symmetry and reciprocity. So for this question, for the reciprocity basically, what is the meaning of symmetry here? Symmetry, if you see the remembering is very easy. This for the symmetry of symmetry, I'm writing here reciprocity. If you're taking the Z parameter here, and you're taking the Y parameter here, the condition of symmetry basically is equal to Z11 is equal to Z22 and the Y11 is equal to Y22 and the reciprocity basically Z12 is equal to Z21 and Y21 is equal to Y22. If you're facing any doubt, just let me know. Okay. If you wanted any clarity at any point of time. Okay. So what is the correct answer for this? A two-port network, that is the Y, basically the Y matrix. So in this situation, the Y21 is equal to Y12. That is the second option is actually correct. Okay. If you're facing any doubt, just let me know. If you wanted to clarify anything. Okay. Let's move forward. Try to solve this. So a two-port admittance matrix you have to find out what is the value of the admittance matrix. So the admittance matrix is such that when you have this two-port network, this is the two-port network. So this is basically the V1 and this is the from here side this is the V2 voltage and the current which is entering here is the I1. The current which is entering here is the I2. Okay. So the matrix when you form this two-port network of the Y parameter matrix, so it will come out to be I1, I2 in the input side is equal to Y11, Y12, Y21, Y22 is equal to V1, V2. Okay, you can write the input or the output parameters in terms of the Y matrix. That is basically equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Okay. You just have to find it out this Y parameter Y11, Y12, Y21, Y22. Okay. Right in terms of the V1, V2, this is the actually the V1. Here, this is the I'm assuming this is the plus, this is minus, this is the V1, and the current which is entering the two-port network is I1. And the current here entering is the I2, and the voltage across here is the V2. You just have to write in this form and you have to get the Y matrix. I'm giving you a few minutes of time. Just let me know if you face any doubt. If you wanted me to revisit this thing, that is also fine if you joined late so that I can recap your what I have taught. If you're facing doubt, just let me know if you are facing doubt. I can recap what I have told in the previous 20 minutes. So I got one question as this, sir, in the table you wrote, can you read out Y parameter reciprocal condition? Okay, so this is basically the reciprocal condition, the Z parameters. Let me again go through that. So important thing here is the you have to remember the what is the input parameters in the inputs means variables in the different parameters. Suppose I am talking about the Z parameters. If you see that, what are the input parameters here? Let me take another color here. V1, V2. What you have done, you have represented in terms of the I1, I2. What you have got that few variables. That is the Z11, Z12, Z21, Z22. So that is basically the Z matrix. That is very important in finding out the questions, solving the questions. So in the each type of parameters, you get one matrix, okay, in terms of like this, y11, y12, y21, y22, okay. So that kind of, if you see here, the input variables y matrix, I1, I2, in terms of what? V1, V2, okay. So these are the five parameters which is important in the two-port network. Second is that if these are the two-port network, what is the condition for the reciprocity or the symmetry basically? If you see here, the condition of symmetry here is the Z11 is equal to Z22, and the condition of reciprocity is the Z12 is equal to Z21. Just remember like this, symmetry means same variable. If you see, that is the trick to remember Z22 here. So these are symmetry means Z11 will be equal to Z22, and the reciprocity, the Z12 is opposite. Z12 will be equal to Z21. Similarly, if you follow in the Y parameters also, you will get the same kind of structure. But in the ABCD or the H parameter, it is bit different. In the condition of symmetry, A is equal to D. It means that A, B, C, D parameter which you got in the tree parameters, this the opposite diagonal elements will be the same. And for the condition of reciprocity, the determinant of ABCD matrix is equal to 1. That is equal to AD minus BC equal to 1. Okay, basically. Okay. Z and Y you got. ABCD is simple that diagonal elements are equal for the symmetry, and for reciprocity, determinant of it is equal to 1. For the H parameter, that is equal to similarly that H11, H12, H21, H22, its determinant when you take, it is equal to 1. Getting my point? So in the ABCD parameter, reciprocity condition, determinant is equal to 1, but in the H parameter, symmetry condition is the determinant is equal to 1. And here also the diagonal elements are means opposite diagonal elements are same. H12 is equal to H21 but negative times. Okay. So these are the table for the symmetry and reciprocity, which we have seen here also, that the two-port network is reciprocal if Y12 is equal to Y21. That is opposite. If you see here, the Y21 is opposite and the Y12 is opposite. And this, what is this? Y11 is equal to Y22. It is the condition for symmetry basically. Getting my point? So this is a kind of symmetry. Let's try to find it out this Y admittance matrix. I hope I have cleared your doubt. Okay, let me solve the first problem. After that, I will give the other problems to solve by you. Let's see how to approach these kind of problems basically. So it's important that the approach part should be important. Okay, let's see. So now if you see that I have to find it out admittance matrix. So important first step is that what matrix, okay. Step one is see what matrix you wanted to find it out. What parameters you need to know. What matrix out of Z, Y, H, T or G. Okay. Now here is the Y matrix I have to find. Step two is write the relation. Relation what I have told in the second slide. What is the relation of the admittance matrix? What is the input variable, output variable? Input variables here is I1, I2 is equal to Y11, Y12, Y21, Y22 is equal to V1, V2. Okay. So this is a second step. that you have to remember that what kind of matrix you wanted to find it out, first step. Second is the what is the input variables into that and what are the output variables. So here the input variables are I1, I2, and here the output variables are V1, V2. Okay. Now what step 3 is, go to the network which is being given and try to find it out the relation between I1, V1, I1, V1, V2 and I2. You need two equation basically. Because in here also if you see, let me take another color. Here also if you see here, you will form the two equation basically. I1 is equal to Y11 times of V1 plus Y12 times of V2. And similarly, you will get the second equation from here, that I2 is equal to Y21 V1 plus Y22 times of V2. So these are the two equations basically. So now I have to also, I also have the network. Now I have to find it out what is the value of equations network basically in terms of that. Okay. And this is the V1 which we have seen here, that this is the plus minus V1, and the current which is entering into that, this is the I1, and this is the V2, and the current which is entering here is the I2. Okay, this is a similar structure. It is a standard form of the two-port network. Let's apply that. Let's write the equation. Step 4 is write the equation. Okay, means by applying KVL or KCL. Let's write the first equation. If you see that, you can write V1 is equal to, because the V1 will be appear across here. So the V1 is equal to the current which is flowing here. Okay, times of 5 plus times of, suppose this is the V1, this is the V2. So the V1 is equal to V2 plus the current which is flowing through the 5 ohm resistor. Okay. So what is the current which is flowing to the 5 ampere? You can write it like this. I1 is equal to V1 times of Y, V1 times of Y plus times of current which is flowing to the 5 ohm resistor. Suppose I have taken there the I dash. Okay, this is the I dash. Okay, because I is equal to V is equal to IZ, or I you can represent in terms of V by Z. So the 1 by Z is Y is equal to the V. Okay, getting my point? So let me duplicate it. Have you got the things? That now you have to find it out. So let's put this equation, this I dash value into this first part. Let's take it. So what we have got? We have got that I1 is equal to V1 times of Y plus I dash. And the what is the V1? V1 is equal to V2 plus I dash times of 5. Okay. Let's put this I dash value here. V1 is equal to V2 plus I dash. What do you got the I dash? V1 times of Y. Sorry. This V2 plus I dash. I dash is I1 minus V1 times of Y times of 5. What is Y? Y here is the Y is equal to 1 by 10. That is equal to 0.1. Okay. Because this is given, what is given here? Resistance. What you wanted to find it out? The admittance. Admittance is equal to 1 upon impedance. Write it the equation. V1 is equal to V2 plus I1 minus V1. What is the value of Y1? Y is equal to 0.5 is times of 5. So the V1 is equal to V2 plus 5 times of I1 minus 0.5 times of V1. Rearrange it. After rearranging, what you get? 5 times of I1 is equal to 1.5 times of V1 minus times of V2. Getting my point? So the I1 is equal to zero point 0.3 times of V1 minus zero point 0.2 times of V2. Here, getting my point. So what we have got here? Let me take another color. Here we have got that I1 is equal to zero point 0.3 times of V1 minus zero point 0.2 times of V2. Okay. What was the standard? Standard word also like that, no? So if you see here is standard, I1 is equal, you want in terms of V1 and V2. Here if you see, what you want V1 and V2 terms, Y11 and Y12. What is this? This is actually the Y11. What is this? This is actually the Y12. Getting my point? So in the questions, also in the solution options, if you see the first option, that is actually matching with this Y11 and Y12 parameters. Okay, let's revisit the question. Step one is that what matrix you wanted to find it on. We wanted to find out Z, Y, H, T or G. Okay, second step is that you have to remember the standard matrix formation. What is the input variable and what is the output variable? Here the input variable is I1, I2, output variable is V1 and V2. This is the standard. Okay, if you wanted to follow and write the any kind of Z matrix for any network, you have to take the input variable as I1, I2 and output variable as V1 and V2. Now the third step is that go to the network and try to write the equations in form of any kind of. You need the two equations because you have the two equation standard equation. So you need the two equation basically. Okay. And after that, try to apply the KVL and KCL and try to write the two equations. Here, if you see here, I also have wrote the one equation here. Okay. So after one equations, I have got the I1 value as a function of V1 or V2. If you see, this is the constants only, no? Y11 and Y12 is just a constant. So these are the constant times of the output variable, that is the V1 and V2. Okay. So the option 1 is matching. Let's try to write the second equations also. If you wanted to write the second equation in terms of the V2 and all, so in that situation you have to know the, suppose this is the actually the circuit, that is the 5 ohm and this is the 10 ohm and this is the 10 ohm. What is the two-port network? V1 is the input side and the current I1 will inject into that. And what about the V2? V2 is the output side and the current I2 will be coming into the two-port network. So this is the standard two-port network. Now the thing is, I have to find out the second equation basically. If you see that here, the current which is going into this, what it will be equal V1Y. The current which is going here, it will be equal to V2Y. Okay, same equation that I is equal to V by Z, or you can write it as V is equal to I times of Z, or you can write I is equal to basically like this V times of 1 by Z and Y by Z is equal to V times of Y. I is equal to V times of Y. Okay. So the current which is going here, suppose I have taken this as the I dash. Okay. So I is equal to I1 is equal to V1Y times plus I dash. Okay. Similarly, when you see the I2, I2 is also equal to V2 times of Y minus times of I dash. Okay. Added both the equation. This is the Y1 basically, and this is the Y2 because that this is the opposite. Okay. Equal values, but you can take the different values for that. Y1 and Y2. Add it in. This is the first equation, this is second equation. Add both. You get I1 plus I2 is equal to V1 times of Y1 plus V2 times of Y2. What is the value of Y1 and Y2? Is 1 by 10 basically. 1 by 10 here, 1 by 10 here. It is 0.1. So you get zero point 0.1 times of V1 plus 0.1 times of V2. Now the thing is, you got the two equations here, but you need the equation in terms of like this. I1 is equal to Y11 times of V1 plus Y12 V times of V2 and I2 is equal to y21 times of V1 plus y22 times of V2. Getting my point? So here we have already got I1 is equal to zero point 0.3 times of V1, I1 is equal to zero point 0.3 times of V1 minus zero point 0.2 times of V2. One equation we have already got. What you have to do here, now the second equation, what you need? You need here, we take an I2 as a function of V1 and V2. What you have got here? You got the I1 plus I2 in terms of V1 and V2. What you could do? You could put this value of I1 here so that it can be replaced in the format of V1 and V2. Let's put here. So what you will get? I2 plus the I1. I1 is zero point 0.3 times of V1 minus zero point 0.2 times of V2 is equal to zero point 0.1 times of V1 plus zero point 0.1 times of V2. Rearrange it. I2 is equal to minus zero point 0.2 times of V1 plus zero point 0.3 times of V2. Okay, getting my point? So now you have got the I2 as a function of V1 and V2. Okay, so the what is the overall matrix you will form? That will be equal to zero point 0.3 because this is the y11 and this is the y12, that is minus zero point 0.2, and here is the zero point 0.2 and zero point 0.3. So this is the overall Y matrix. Okay. Now there is a any doubt in this? Any doubt? If you are facing any doubt, just let me know. I will clarify that. Okay. I hope I have cleared this doubt. So the important point is that you have to make the equation in such a way that you get the input variables of that parameter and also the output variables in terms of that. Okay. Input parameter in terms of the output variable. Here I have to find it out the Z parameter basically. So I have to write the equation in form of V1 and V2. I1 equation in terms of the V1 and V2 and the I2 equation in terms of the V1 and V2. What we have done, we have got zero point 0.3 minus zero point 0.2 minus zero point 0.2 zero point 0.3, which is matching with the first option. Okay, that is the important thing you should remember. Try to find out this. This is very simple. I will write the equations if you need that. So let me write the equations. You could start solving. So I1, I2. Here the Z matrix you have to find it out. So it is equal to I1, I2 is equal to Z11, Z12, Z21, Z22 times of V1 and V2. Try to solve this. Try to write the equations in terms of I1 equation in terms of the V1 and V2 and the I2 equation in terms of the V1 and V2 and try to find out the Z parameters. Oh, sorry. Here there is a one draw. I have wrote the opposite. V1, V2 is equal to Z11, Z12, Z21, Z22 times of I1 and I2. So this is the for the Z matrix. You have to write the I1 and I2 in terms of the V1. Try to write this and let me know which option is actually correct. Okay, I got one answer as option A. Let other two also to solve. And also, Shakti, please check your answer. Re-verify. Okay. Meanwhile, the other could solve the question. If you face any doubt in between means sessions, just let me know. It's simple only. Only you have to write the I1 and V1 and V2 equations in terms of the I1 and I2. Rearrange it, put the equation 2 into the equation 1. You can do anything and just you have to find it out the V1 in terms of the I1 and I2. And the constant which you get, that is simply equal to Z11 or Z12. If you're facing any doubt, just let me know. But I request everyone to solve that so that I can get the confidence that you are getting the things. Okay, let me give the solution for this. After that, you could try the other one. Okay, let me solve this. So let me broke this into the two parts. So the first equation I have got is equal to I1, that is equal to 2V1 times plus V2. Listen here, that I1 is equal to 2 times of V1 plus V2. That is the first equation. And the second equation is that I2 is equal to V1 plus V2. Okay. Now what you have to do? You have to write in terms of like this. Okay. What you want. Okay. You want V1 is equal to Z11 times of I1 plus Z12 times of I1. Forget this. You just need V1 as a function of I1 and I2 in terms of I1 and I2 only. Let's try to write it. If you see here, the I1 is equal to 2V1 and V2. So what is here? It is the I1 in terms of V1, I2. Rearrange it. So you can write it like this also. The I1 is equal to V1 plus V1 plus V2. Why I have wrote this like this? Because in the second equation, that is equation 2, you have already have the value of V1 and V2. You can directly put it here. When you put, you will get the I1 is equal to V1 plus I2. Rearrange, you what you will get, V1 is equal to I1 minus I2. Getting my point? So the V1 you have got in terms of the I1 and I2, what is needed basically. If you see here the V1 equation, okay, this V1 is K times of Z11 times of I1. What is the here? V1 is equal to 1 times of I1 plus minus 1 times of I2. It means that this 1 is equal to Z11 by comparison, and this will be equal to Z12. Getting my point? So this is the equations that you have got the V1 in terms of the I1 and I2. Just you have to rearrange it. What about the second equation? If you see, this you have already got, okay, V2 equation. Now you need the V2 equation. So V2 is equal to I2 minus V1. But the V1 you have already got. V1 is equal to I2 minus V1 you have already got. How you have got? This is the value of V1. Just you have to put it here in terms of V1 is equal to I1 minus I2. What you will get? You will get 2 times of I2 minus I1. Okay. So what you have got currently? You got the two equations here. Two equations. How two equations? This equation 1, V2 in terms of I1 and I2. Here the V1 in terms of I1 and I2. So the first equation V1 is equal to I1 minus I2. Second equation V2 in terms of I1 and I2, that is the 2 times of I1 minus I2. What matrix you have got? You have got as like this V1 V2 here is equal to 1 minus 1 2 minus 1 times of I1 and I2. What is the correct answer here? So 1 minus 1 2 minus 1. 1 minus 1 2 minus 2 minus 1. I think none of the answer is actually correct. So the here if it could be written 2 times of minus 1, so it could be correct. Okay. So just you have to rearrange and write in terms of the V1 and V2 in terms of the I1 and I2. Then you could have seen the what is the correct values basically. Okay. Any doubt in this?
Sir,
Yeah.
um, so shall we try that V1 by I1 equal to Z11 and I2 equal to 0? So in that method, shall we try, sir?
Yeah. Let me give the
But
second
while I'm
method.
trying this method, I got different answer. That's why I'm asking, sir.
Okay. Okay. Maybe any mistake could happen that in the while solving. So let me give that second method also, that I1 is equal to 2 times of 2 times of V1 plus V2, and this is the first equation, and which was given. Second equation was that I2 is equal to V1 plus V2. So this is the second equation. Okay. The matrix which you have got, that is the equal to V1 V2 is equal to Z11 Z12 Z21 and Z22 times of I1 and I2. Okay. So when you write in the equation form, you got the V1 is equal to Z11 times of I1 plus Z12 times of I2, and the V2 in terms of the Z21 times of I1 plus Z22 times of I2. What is the actually the meaning of Z11? Z11 is equal to V1 I1 when the I2 is equal to 0. It means that when the output side is open circuited and you wanted to find it out the relation between the V1, that is the input voltage, and the input injected current into the two-port network, that is the V1 by I1. Okay. Through this part, let's try to put in this equation and try to get the correct answer with this. So let's put I2 is equal to 0 in the first and second equation. What you get? First equation, there is no effect, that you don't have any V2, but second equation, when you put the I2 is equal to 0, will be equal to V1 plus V2. Okay. So the V1 here is equal to minus times of V2. Put in the first equation, what you get? I1 is equal to 2 times of V1 plus what is the V2? V2 is minus V1, which will be equal to V1. So the V1 by I1 ratio will be equal to Z11, which is equal to 1. Okay, so this is also a one way to find it out. So you can compare. Let's find it out the Z12. What is the value of Z12? Z12 is equal to basically V1 by I2 at I1 is equal to 0. Okay, so this we have calculated for Z11. Let's try to find it out for the Z12. We will see. Put the I1 is equal to 0 in the first equation. What you get? 0 is equal to 2 times of V1 plus V2. So in the second, so from here you will get the V2 will be equal to minus 2 times of V1. Put in the second equation. What you got? I2 is equal to V1 you needed. What is the value of V2? V2 is equal to minus 2 times of V1 is equal to minus times of V1. So the Z12 will be equal to V1 divided by I2 is equal to minus 1. Okay, that is actually when you see from the matrix itself, this is we are getting here 1 minus 1 we have got. Here also you are getting Z11 as equal to 1 and also Z12 is equal to minus 1, which is actually matching with the both. Let's try to find it out the other Z13. What is the value of Z13? Z13 will be equal to, sorry, Z21 basically. Z21 when you go to find it out, it is equal to V2 by I1 at I2 is equal to 0. It will be equal to V2 times by I1 at I2 is equal to 0. Okay, put it in the equation. First equation, no effect because I2 is there in no term. Put it in the second equation, what you got? I2 when you put it as a 0, you will get V1 is equal to minus V2, similar fashion. Put it in the equation 1, I1 is equal to 2 times of V1, but you don't need V1, that you need the V2. V2 will be equal to, V1 will be equal to minus times of V2 plus V2, which will be equal to I1 is equal to minus 2 times of V2 plus V2, which will be equal to minus times of V2. So the Z21 you will get the V2 by I1. V2 by I1, what it will equal to? Minus 1. Okay. I think I have got the wrong answer in the first part. So you can verify the methodology and the check whether it is coming correct or not. So it will be equal to 1 minus 1 minus 1. I think you have got the correct values. Okay. So it will be equal to, I think, like this, the B option, basically. 1 minus 1 and minus 1 we have got. I think the second option could be the correct. Okay. So maybe in the process I have made some mistake. So you can verify at your home. Okay. So this is a could be a second kind of methodology to find it out the Z11, Z12, Z21 or Z22 matrix element basically of a Z matrix. Any doubt in this?
Understood, sir.
Okay. Okay. Let's move forward. So in the first problem, we have seen that how the matrix is important with the input parameters and the output parameters and how you have to write in the terms. Okay. In the second also, it is important that when you know the input variables and the in terms of the output variable when you wanted to write it out. This is the second question. Here, what is the thing is, you know the Z matrix. Now you have to find it out the Y matrix and then you have to write the Y22 matrix element. Okay, try to write in the terms Z. I will write here the equations basically. So the for the Z matrix variables are V1, V2 is equal to Z11, Z12, Z21, Z22 times of I1 and I2, and for the Y matrix it will be equal to I1, I2 is equal to Y11, Y12, Y21, Y22 is equal to V1, V2. Okay. So here you know what you know here. You know this matrix. This is already given here. You have to write two equations for from that equations itself. What you have to find it out? You have to find this. Okay, getting my point. So you know the equations V1 and in terms of the I1 and I2, write that two equations and try to rearrange and try to find out what is the value of Y22. You can also do like this. What is the value of Y22? Y22 will be equal to I2 by V2 at V1 is equal to 0. It means that when you kept the V1 is equal to 0, you will get the I2 by V2 matrix. From any method you could try and let me know what is the correct answer. If you're facing any doubt, just let me know. Okay, I got one answer as option D. Okay. Re-verify whether it is correct and let other also to solve. Last 1 minute. Okay, let me give the solution for this. Okay. So in the question itself, it is mentioned that the Z matrix is already given, and you have to find out the Y22 matrix of the Y matrix. Okay, Y22 element of the Y matrix basically. So the Y matrix, Z matrix, we have already know that what is the value of Z matrix when you know this Z11 and parameters. It will be written like this: V1 is equal to Z11, which is equal to zero point 0.9 times of I1, because here it is written here now. So this is the Z11, and this is the Z12, and this is the Z21, and this is the Z22 basically. So it will be equal to zero point 0.9 times of I1 plus zero point 0.2 times of I2. The what is the value of V2? V2 will be equal to zero point 0.2 times of I1 plus zero point 0.6 times of I2. Okay. Now the thing is, you have to find out the what is the value of Y22. Y22 you already know, it is will be equal to I2 by V2 at V1 is equal to 0. Let's put the value of V1 is equal to 0 in the equation first. You will get 0 equal to, let me take another pen, zero point 0.9 times of I1 plus zero point 0.2 times of I2. This is the one equation, okay? Or you can write when you what you wanted to put it this in the second equation. Basically, you wanted the I2 value zero point 0.2 times of what is the value of I1? I1 is equal to minus zero point 0.2 divided by, okay, minus, oh sorry, here you remove this. Basically 0 is equal to here, that V1 is equal to 0, it will be equal to zero point 0.9 times of I1 plus zero point 0.2 times of I2. Okay, put this in the second equation, you will get V2 is equal to zero point 0.2 times of I1. I1 is equal to minus zero point 0.2 times of I2 divided by zero point 0.9 plus zero point 0.6 times of I2. Rearrange it, you will get V2 is equal to I2 zero point 0.6 minus 0.04 divided by zero point 0.9. Okay, let me find it out. What is the value? Will come 0.04 divided by zero point 0.9 and zero point 0.6 minus, you will get 0.55. I think I'm getting some wrong value here. It will be equal to I2 by V2 at V1 is equal to 0. So V1 is equal to zero point 0.9 times of I1, zero point 0.2 here, zero point 0.2 times of I1. We have kept that V1 is equal to 0 here, zero point 0.9 times of I1 plus zero point 0.2 times of I2, and V2 is equal to zero point 0.2 here minus zero point 0.2 I2, 0. Zero point 0.2 I2 divided by zero point 0.9, which is the I1 plus zero point 0.6 times of I2, which you have rearranged. V2 is equal to I2 is equal to zero point 0.6 and zero point 0.2 multiplied by 0.04. So it will be coming 0.04 divided by 0.9. 6 minus answer, it is coming 5 by 9. Okay. So what I am getting, point this equal to I2 times of 5 by 9 basically. So what we need Y22 basically, Y22, which is equal to I2 by V2. Okay. So the I2 by V2 you will get 9 by 5, which is equal to 1.8. Getting my point? So just what you have to do, you what value, if it is a one element it is needed, try to use this method. Okay. In that equation, if it is a two equations is already given, you have to keep something zero so that you can get the one element of that particular matrix. Okay. So here the option 4 is correct. Let me give you one more method to solve this kind of any doubt in this method. Okay. Okay, let me give the second method. Second method is that when you have the Z matrix and you have to find it out the Y matrix. So Y matrix is generally equal to the generally all the times it is equal to Y is equal to Z inverse. Okay. So when you need the Z matrix, try to find it out the inverse of that and you will get the Y matrix. Suppose you have the 2 cross 2 matrix A, B, C, D and you wanted to find it out the inverse of that. There is simple trick that 1 upon AD minus BC basically means the determinant of that. That is the AD minus BC. And here what you have to do, you have to exchange the diagonal element. That D here, A here, and the off diagonal element you have to negative that minus B and minus C. So this is basically the inverse of that. Okay, matrix. Let's apply in this problem. What is the given here is the 0.9, zero point 0.2, zero point 0.2 and zero point 0.6 is given. Okay, let's find out the inverse of this. What will be the value here? This will be equal to AD minus BC. AD will be equal to zero point 0.9 multiplied by zero point 0.6 minus 0.04. It will come out to be 1 upon zero point 0.5. Here what you have to do? You have to reverse it. Reverse means zero point 0.6 here, zero point 0.9 here, and off diagonal element you have to negative it. Minus 0.2 minus 0.2. So this is the basically Y matrix. So this is the Y11. Of course, this is multiplying inside of that. It means that this is by zero point 0.5, this by zero point 0.5, this by zero point 0.5, and this by zero point 0.5 is actually the Y matrix. So this is the Y11, this is the Y12, and this is the Y21, and this is the Y22. Okay. Here, what is the value of Y22 here? Y22 is equal to 9 by 5, which is similar what we have got here. That is equal to 1.8. Okay. Getting my point. Just you have to find it out the Y inverse, then take the what is the value of Y22 there. Okay. Any doubt? So you have got the two methods to solve this. Means three kind of problem you have seen currently. One, when you have the topology, means this problem. You have the network topology, then you can simply by knowing the matrix, you can find it out that admittance matrix or any kind of matrix. Second kind of problem we have seen, you have the certain equations you can write, rearrange, and you can get the values of the another matrix. Third kind of problem that you have seen that one matrix, one parameter matrix you know, how could you can find out the second type of parameter matrix? Getting my point? So three kind of problem is we have solved currently. Any doubt in this? If you feel any doubt, just let me know. Okay. If you don't have doubt, just move forward. Try to solve this. This is simple and I just you have to write the KVL and KCL equations and let me know what is the correct answer. Z matrix you have to find it out. Z matrix you already know that V1, V2 is equal to Z11, Z12, Z21, Z22. You have to just find out this Z matrix and this is the output here. Okay. So 500. Try to solve this. Okay, I got the one answer as option D. I request others also to solve. Okay, re-verify whether it is correct or not. Okay, I got the answer as C. It was changed. Okay, last 1 minute. After that, I will give the solution for this. Okay, let me give the solution for this. Okay, so in this question, it is asking that what is the Z matrix for this network. What you have to do, just apply the KVL basically. Okay, KVL or the KCL and write the two equations. So let's try to find out the first equation. If you could see that here the current I1 is coming and here also I2 current is coming. Okay, so here I2 coming and this is I2. And what is going inside of this? This is the basically I1 plus I2. Okay, so first equation we have what we have got V1 is equal to, because this is the voltage drop which is appearing across the Z1. So the V1 is equal to I1 plus I2 times of Z1, that is equal to I1 Z1 plus I2 Z2, or you could write it like this: Z1 times of I1 plus Z2 times of I2. Sorry, this is also Z1. So this is Z1 times of I2. Okay. If you compare with this values Z11 and Z12, this means that that is same values Z11 and Z12, because this is the V1 is equal to I1 and I2 terms. Okay. If you could
Sir,
see, yeah.
sir, could you discuss the assignment problems? Assignment week 9.
Assignment problem basically, you have to solve it by yourself, because I could give the methodology how to solve it, because the same pattern I follow, that I give the some amount of questions which could lead to solve your assignment, which is the upcoming week. But I cannot directly solve the all the means assignment problem basically. That is means that is a practice for you to check. Okay. I give the same level of problems in the other side, but you have to solve the assignment by yourself. Okay. If you feel any doubt in the assignment problem, just let me know. Okay. But I cannot give the solution for this. But I have seen that the other TAs are doing that. But you could follow the other TAs also because there are three TAs are there, no? So the two TAs are basically they are giving the assignment problems and solutions of that. So you could follow that because directly solving that assignment problem that will be not making sense. You have to solve the other problems which I will give you. Then you should solve the assignment problem by yourself and think that okay, how it could be solved. Okay, getting my thought process. Oh, that is the majorly means ke how I actually go through this assignment problems and all. Okay, but you could still feel that ke it is you if you want anything to discuss by me, just let me know the question and numbers and all so that I can put in my slide so that we can discuss it. Okay, just let me know what kind of which assignment and which problems so that I can keep in my slides and discuss in during the process of the lecture itself. Okay.
Week 9, sir.
Week 9. Okay. Week 9 problems are similar pattern. What I am giving now, I have seen the problems that are in similar pattern. Means you have to make equations and you have to get the parameter values. That is a similar kind of problems which we are actually dealing here. Let me show you why I am saying that. If you could see this problem, that is the similar problem which is given in the question number one. Okay. When you try to solve this problem, you will get the feel of how to solve the assignment 9, the first problem. Okay. If I could solve the assignment 9, the first problem, that there will be no making sense that means that genesis of that assignment could go into the win. Okay. Getting my point. So I will give the similar kind of problems, but you have to solve the assignment by yourself. That is the actually requirement by you. Okay, getting my point. But I will see that in the assignment 9 problems how it is difficult, and I will keep in the slide. But in the next session that will be possible, not in the today's session. Okay, getting my point.
Okay, sir.
Yeah. So what I will teach here that will help you to solve the assignment 9, but it is your responsibility to solve it by yourself. Okay. So let me go through that this problem. So what we have seen that ki V1 equations we have found it out that V1 is equal to Z1 I1 and Z1 times of I2. What we have got that is Z, this is basically the Z11 and this is equal to Z12. If you see the options also, this will be discarded because this is not matching, and this also will be discarded because the values are same. So the option B and option D could be a solution. Okay. Let's try to find it out the second equation. If you see in this problem, the current, if you see here, this is the V1 because the voltage drop here. And the what is the voltage drop because the Z2? It will be equal to I2 times of Z2. And this is the voltage across here is the V2. Okay. Try to write the KVL in this loop. When you write the loop, you will get V1 is equal to minus times of I2 Z2 plus V2. Okay. Now the thing here is that you need the V2 in terms of IN and I2. But what you got? You have got the V2 is equal to V1 plus I2 Z2. But we have already got one equation that V1 is equal to Z1 I1 plus Z1 I2. This is the equation we have already got from the equation. Try to keep into this equation, this let's equation 2, like equation 1. Put the equation 1 value in the equation 2, we will get V2 is equal to Z1 times of I1 plus Z1 times of I2 plus Z2 times of I2. Okay. So what you will get Z1 times of I1 plus Z1 plus Z2 times of I2. If you compare with this Z21 and Z22, you will see that this is the value of Z21 and this is the value of Z22. Okay. So the option D is actually matching. This is the also Z11, Z11. We have got Z11 here, Z11 plus Z1 plus Z2. Okay. So this kind of problems is actually important to understand that when you write the equations, try to write in terms of the KVL and the KCL, you will get the answers basically. Okay. Let's move. Any doubt in this? If you don't have any doubt, just let's to move to the important part, this problem. Try to solve this. Here what is asking that it is a two-port network it is given, and this H11 parameter is actually they wanted us to find it out. Okay. They need the H11 parameter. H11 they have already given that H11 is equal to V1 by I1 and the V2 is equal to 0. It means that this V2 is actually short circuited. Okay, getting my point. This V2 is got short circuited. You have to find it out the ratio of the V1 and I1. Try to solve this. After that, I will give the solution for this. You can also make the circuit like this also. Okay, so this is actually the one resistor here. And when this terminal got short circuited to this, you can directly connect it here. Okay, and try to make it like this. You can make it, this is the 1 ohm resistor, this one, and this is also the value of dependent source, that is 2I1, that is connecting here, because this terminal and this terminal got shorted because the V2 is equal to 0, and this you can write it like this. This is the 1 ohm, this is also 1 ohm, and this is the I1. You can just have to apply the KVL here. Getting? Try to find out the what is the value of V1 in terms of I1. Just write the KVL equation, you will get the answer. Or apply the KCL at this node, at this node. If you're facing any doubt, just let me know. Last 1 minute. Okay, I got one answer as minus 1.5. Okay. Re-verify whether it is correct or not. Okay, zero point 0.5. Okay. That is actually correct. Okay, let me give the solution for this. So when you see this, if you see this 1 ohm, this 1 ohm, and this 1 ohm, they are actually in the parallel. Okay. So if it is in the parallel, you can simply write it like this. This is the 1 ohm and this is the parallel. So equation will be something like this. R1 R2 divided by R1 plus R2. So the it is equal to 1 cross 1 divided by 1 plus 1, that is equal to 0.5 basically. Okay. So here it is equal to zero point 0.5. Okay. And this it is already given. It is the current which is equal to 2 times of I1. Okay. And the I1 current is coming here. And this is value is equal to V1. Okay. Now the thing is, I have to find it out the KCL equation at this node. Okay. If the 2I1 is going here, so the 2I1 is going here and I1 is coming here, it means that I1 current should also come from here. Okay. So that the 2I1 can flow the out of that node. So it is coming I1 basically here. So that's why it will become 2I1 here. Okay. So let's apply the KVL. Let's apply the KVL in this loop. You will get V1 is equal to 1 times of I1 minus, why minus? Because it is opposite direction. So it is the positive here, negative here. That's why it's a minus zero point 0.5 times of I1, which will be equal to zero point 0.5 times of I1. So what will be the value of V1 by I1? It will come out to be 0 0.5. Okay, getting my point? Any doubt in this? So this will be equal to zero point 0.5 ohms. Any doubt in this? So network analysis is very important, and also the KVL and KCL equations will follow you at the end as well. Okay, so this is the most important. You should try to analyze and write and form the equations and all. Okay, that will be make you more understandable of these equations. Okay, any doubt? Okay, if you don't have any doubt, just let move forward. Try to solve this. Try to solve this problem. Try to find out the impedance matrix of this. That is basically equal to V1, V2 is equal to Z11, Z12, Z21, Z22 times of I1 and I2. Just you have to write the KVL equations. KCL equation or KVL equation, you will get the answer. Okay, I got one answer as the option 1. Okay, just wait for 30-second more to let others also solve. Okay, listen here. I'm giving the solution for this. So if you see here in this problem, so there you have to form the two equation basically. So try to apply the KVL in this loop. If you see this is the I1 current coming here and the I2 current coming here. So the I1 plus I2 will go into this, okay? And this voltage which is appearing across here, this is simply the V1. So you can write it like this: V1 is equal to I1 plus I2 times of R. Or you can simply write it as Ri times of I1 plus R times of I2. Okay. If you see in this, this apply the KVL in this loop. That is a similar na, V2 will be equal to V1 because they are coming across the R itself. So that's why the V1 will be equal to V2. That simply you can write it like this: R arms of I1 plus R times. Okay. So what you got? You got the two equations here, V2 in terms of the I1 and I2, and also you have got the V1 in terms of I1 and I2. So you can write it like this: V1 and V2. V1 is equal to R times of I1 plus R times of I2. Similarly, this is also equal to R times of I1 plus R times of I2. So that's why the option 1 is actually correct. Okay. So the matrix will be formed like this: R, 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 R. Okay. Let's move to the last problem. Any doubt in this? Okay, let's move to the last problem of this set. Try to solve this. You have to form the Y matrix basically. So the Y matrix will be like this: I1, I2 will be equal to Y11, Y12, Y21, Y22. That will be equal to V1, V2. Okay, try to solve this. You just have to write the equations. Okay. Anyone? Okay, let me give the solution. Listen here. So this is last problem. Option two I got. Okay. So okay, let me solve this problem. Listen here. If you see in this problem, what is asking that you have to find out the y parameters. Okay. It means that you just have to make the two equations and in terms of the I1 and V1 and V2 basically. The I1 and I2 in terms of the V1 and V2. If you could see that this from here you can write one equation like this that I2 or I1 will be equal to minus times of I1 because they are in the flowing in the same line basically. So that the both currents should be equal in magnitude but the opposite in phase because they are in the opposite direction means 180-degree in opposite in phase. And you can write this is the equation 1 you got. Let's try to write the equation 2. Okay. Try to apply the KCL in this loop, KVL in this loop. What you got? This is the voltage drop here. It will come out to be 5 times of I1. So it will come out to be V1 is equal to 5 times of I1 plus V2. Okay. So if you rearrange this equation 2, you will get I1 is equal to V1 minus V2 divided by 5. Getting my point? So it will become 1 by 5 times of V1 plus minus 1 by 5 times of V2 which we needed because this is the y11 and y12 parameter basically. This is the y11 and this is the y12 parameter. From the options if you see that y11 we have got that 1 by 5, the option 2 will be the correct. Okay. Let's try to find out the I2 equation. If you see that I2 is equal to minus times of I1. So if you multiply minus in the I1 equation, you will get minus 1 by 5 times of V1 plus times of 1 by 5 times of V2. So what is this? This is the Y21 and Y22. Okay. This is matching with this element. So the option 2 is actually correct. Okay. So that's all for the today's session. I will share this slide and also share this video lecture. Try to solve as much as problems if you can. Okay. So by solving the problems, you will get through that assignment problem. That will make you the easy to understand the assignment problem. Okay. Any doubt in this? Any doubt? Okay. Okay. Thank you so much. So that's thank you for joining today's session. Have a good day.